So we're going to look at the law of cosines, or sometimes called cosine law. So this says for a triangle where little a, b, and c are the side lengths and capital A, B, and C are the angles, as we usually do, then the following is cosine law. So a squared equals b squared plus c squared minus 2bc cosine of a. And then the other versions are just the other ways that you can actually write it. Notice it looks kind of like Pythagorean theorem with this little extra part at the back. But notice a couple things. So if you are dealing with little side a squared, that corresponds to your angle being capital A. Similarly, if little b squared is on its own, then that corresponds to angle B. Little c is on its own, then that corresponds to the cosine of that particular angle. And then notice the other side. So we have b squared plus c squared minus 2, and then those same values are showing up. A and c, those two values are showing up. A and b, those two values are showing up. So it's important to watch that carefully. You can always reference the different versions, obviously, in your formula sheet. And there's two scenarios generally when we use the law of cosines. So one is when you have two sides and the angle between them. So not a perfect pair. So you have two sides and an angle, but it's in between them. Or number two, all three sides of a triangle. So if you have those two situations, then cosine law is a little bit better. So for example, you might have side B and side A, and then you want an angle in between them. So you'd have to have angle C as well. If you have, for example, if you had side B and side C, then you'd want the angle A in between them. Then you can apply your formulas. So if you had the situation of B and C and then angle A in between them, then generally you want to apply the one that has B and C in it and uses angle A. So it would be like the first one. So this would be given, 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 and given. So then we can just apply that formula right away. If you have all three sides, it's also an opportunity to use your cosine law. And then it just depends on what angle you care about. So say you had all three sides, but you wanted to find angle B. Then you could actually say, okay, which one has angle B involved in it? It would have to be the second one, right? You have to have that one as an unknown in between it. So it does take some time and practice to pick the appropriate version of when you're actually dealing with it. So let's take a look at, say that we wanted to find angle C. So say you had all three sides and you wanted to find angle C. That means you'd want to apply the one that has angle C in it. So it would be like this third formula right here. So I'm just going to write this one down, and then we're going to utilize that one to solve for angle C. So C squared equals A squared plus B squared minus 2AB cosine of C. So we would like to actually solve for C and get C on its own in a situation where we have all three sides of a triangle. So what we actually do is we have to alter it a little bit. So I'm going to bring A squared and B squared to the other side. So C squared minus A squared minus B squared is equal to negative 2AB cosine of C. And I also want to bring over the coefficient to the other side as a divide. So C squared minus A squared minus B squared divided by negative 2AB is equal to cosine of C. And then you notice that you can just change the negative signs, or you can change the opposite signs when you do a divide by a negative, which is why we get this altered version or rearranged version of this formula is cosine of C on this side is equal to A squared plus B squared minus C squared divided by 2AB. So you can use this altered version of the formula, and then we can take that last step, cut off the cosine, and bring it over as cosine to the negative 1 or cosine inverse to find an angle in that particular case. Let's actually take those and do a couple examples of where we're actually finding numerical values associated with them.